Okay, so in this video, page 8, we're finding the area between two curves. The process is there. It's pretty straightforward in that it's very step-by-step. So I'll take you through an example, and then we'll see where we end up from there. So first thing, let me get my line draw tool out. We have a parabola and we have a line. All right, so it's whatever this is, this bounded area, whatever it looks like, it's definitely going to be bounded between an upward facing parabola and a line with a positive slope. So all I'm going to do is just ballpark what that might look like. All right, so there's a line with a positive slope. And here's my parabola. All right. So what they're asking us for is this area here. All right. Now that area is going to start at some particular x value. And it'll also, well, it'll end at some additional x value. So somewhere over here. Problem is, I don't know what those values are. A couple of different ways to do it though. You could use the intersect function in your calculator, or you could just do good old alg1, set these two bad boys equal to one another. And solve. So if I bring over the 4x, I'm going to get x squared. That's going to be minus 2x. Bring over the 45, so minus 48 equals 0. Factor and solve. You know, if factorable, maybe it's not. If it's not, then complete the square quadratic formula. In this case it is though. X minus 8, x plus 6. All right, so that's going to give me two roots, x equals 8 and x equals negative 6. So, negative 6. All right, so now I know what my two bound values are, boundary values. So negative 6 and 8. So next up is to set up the integral. The integral is going to be, if you follow the instructions, it's always the dominant function minus the non-dominant function. All right, so the dominant one is the one that's above. All right, so above, that's if it's from the perspective of x. If it's from the perspective of y, it's the rightmost minus the leftmost. Here it's the topmost minus the bottommost. All right, so topmost function, 4x minus 45, plus 45, sorry, minus the non-dominant, x squared plus 2x minus 3. All right, so we're integrating that over the interval of negative 6 to 8 with respect to x. All right, so I'll do this one by hand, but you could chuck this whole thing in your calculator and call it a day. All right, so I got a little negative coefficient that can go through, so 4x plus 45 minus x squared minus 2x plus 3 integrate dx. Cleaning it up further, we have negative x squared plus 2x plus 48. Again, integrating. But this time I'm actually at the point where I can integrate, so now I'm going to put my bounds back in. dx. Integrate with respect to x. So negative 1/3 x cubed plus x squared plus 48x over the interval of negative 6 to 8. And at this point, you know, pick your poison, it's up to you. In your head, in your calculator, it doesn't make a difference. But, you know, that's really awesome if you could do this in your head. I mean, congratulations. I mean, I can't. I mean, not easily. I might need a few minutes. a little awkward staring at the wall kind of moment, but most likely this is a calculator sort of situation. So, but that's how you would set it up and go through the integration process. But now let me get the old calculator out. So Math 9. I'll go right back to the original. I don't want to take the chance that maybe I made some kind of careless blunder with the algebra. Minus 3, close them up. X going from -6 to 8. And so about 457, well, 457 1/3. They didn't give us a sense of units, so square units. It is an area, so square units. All right, now another quick way to do it that involves less writing. If you take one of the functions and put them in your put it in your calculator, x squared plus 2x minus 3, and the second one, 4x plus 45. You could use second trace 5 in order to find the intersection. I'm assuming that that's something, you know, that you're willing to do. All right, here's what the graph would look like. You know, zoom appropriately. In a lot of cases, you could actually just pull off the intersections just by looking at tick marks, but you know, the scale on this one's a little crazy. All right, my setup's somewhat different from yours, so you just have to kind of imagine that this is working. Second trace 5, enter, 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 will bring you to one intersection. Then second trace 5, scroll over to the other intersection and hit enter 3 times, and that'll get you there. All right. You do need a reasonable window. Once I see that 45, I'm thinking my Y window should probably go into the neighborhood of 100, you know, just to get that 45 somewhere in the middle of my graph. But you can play around with the different zooms and things like that in order to get where you need to go. That's really not why I did what I did. What I wanted to show you is if you have your equations already stored into y1 and y2 because you needed them in order to figure out some characteristics related to the graph, what you could then do is Math 9, y, you just got to remember which one is which. My dominant one was y2. So y2, so alpha trace y2 minus alpha trace y1, x going from -6 to 8. And it'll do it for you because it knows to refer to y2 for the 4x plus 45 and the y1 for the x squared plus 2x minus 3. All right, so this method is only used